is a large-scale research program. In Sweden, we've been focusing on the value chain approach, so everything from raw materials to you have a final asset or service. And I've been focusing in on the building and transport infrastructure. And what we've been doing then, looking into, I guess, mitigation options to reduce emissions from the entire supply chain, and then seeing how could this roadmap look like towards getting to zero by 2045. So it's about looking at what can different supply chain actors do, when can they implement those, and to what degree, what do we see as feasible, and then trying to align this. So that's why we have very much interaction with stakeholders all the way along the supply chain to try to get a feasible and pragmatic approach towards an ambitious roadmap going forward. But in this, I will present a few case studies that we have been looking at, and the focus of our approach is mainly to reduce the embodied carbon. So the carbon farming coming from both the materials used and the transport of those materials and the installation of them into the building. And the main reason for that is that Sweden has gone really far already when it comes to operational emissions. They've been reduced by 2/3 since the 1990s. So on the building level now, building stock level, the majority of the emissions actually come from the embodied emissions. So that's why, hence that focus. And I will look at some of the best practice cases where we combine levers and measures along the supply chain to reduce embodied carbon. And we try with these, we at least maintain, if not improving, the operational carbon of these projects. And what I want to focus to is that what we have looked at, all of these four cases that I will highlight today are cost neutral in the implementation based on like a reference case. And that's mainly due to the applying different types of resource efficiency levers. And so the cases I will do is also looking at different parts of, if we talk about this sufficiency pyramid almost, where we, that is FINA, where we talk about first utilizing what we already have in terms of vacant and shareable spaces. But the ones I was focused on is renovating an existing building, extending an old building, and then also a couple of examples from building new. And I'll start with the renovation case. This was a large-scale renovation of a social housing project. And as you can see in the pictures, it was in really poor condition. It was from the 1940s, and not a lot of maintenance had been done over the course of that period, not sufficient. So it needed to have the windows, facades, and the roof replaced. It needed also, because it was poor energy efficiency, needed additional insulation, a new ventilation system. We also changed the water and sewage mains in the buildings, and also renovated the bathroom and other maintenance, and as well as adding balconies. And the measures taken then was really to look at doing an inventory of what is of sufficient quality that's already in the building that we can reuse. So some of the reuse, for example, radiators, toilets, window seals and doors. And also working quite hard in collaboration with suppliers to reduce the amount of concrete and steel used in the renovation. And doing some product choices for insulation and the facade system as well as working on minimizing waste. For example, some of the things that weren't able to be reused in the building were actually donated to other projects to reduce the amount of waste. They also implemented all transport were fossil-free, and some even electrified. So there was, for example, an electrified crane truck for this project. And the result was that we got 90 kilogram of carbon dioxide emissions per square meter. We normally calculate in gross floor area in Sweden. I know it's different in different countries. And if you see at the bottom here, this is comparing it to a new build. So if we were to build a new, it doesn't include demolition then, but that would be the option for this because it was in such poor condition. That would be, and this would be that's the original baseline that they based the calculations from without doing the measures. and this is where they ended up. So you reduce the embodied carbon emissions significantly. So from the project baseline, it was reduced by about 40%, and also reduced energy consumption in the existing use of the building, while extending the lifetime, of course, of the building. Some of the conflicts and challenges in this was in terms of they wanted to reduce as much as possible, but in terms of the windows, it was too difficult. They were in too poor conditions, so they weren't based on the circularity and the cost. They were looking at taking the windows away and trying to see if they could upgrade them or refurbish them, but it would be 3 times the price, so it wasn't worth it. So in the end, they were also donated to be used for other purposes in other building projects. Some of the success factors in this was to have a reduction of embodied carbon included in the contract requirement with the contractor. They also had a climate coordinator for the specific projects and also did climate calculations, both at the early start and the design stage, as well as in the as-built, how it was in the finished renovation. And as I said, a very close cooperation, both from the client, together with the contractor, as well as the suppliers of material. And you see the end result is quite nice. You wouldn't be able to see that there is reuse in this, for example, and it's significantly increased the living standards for those living in these buildings. Then I'll move on to the next building, which I think is a really interesting project. This was actually an office building from the 1970s in Uppsala, north of Stockholm. And it was meant to be demolished. That was in the plans for it to be demolished. But both the client and the architect pushed for it to be rebuilt instead towards the municipality. And it took quite a bit of discussion and debate, but they actually managed in the end to do it. And really, they're taking circularity to the next level with this project. And they've also used quite a systematic and advanced design and digitization process to both do the inventory of what is there, what can we use, and then keep track of this. So every single material product in the building had like a QR code on it, printed, so they could keep track of it during the course of the project. And so the measures that they've taken is that, if you see here, this is the existing building, they've actually retained 80% of the foundation and the structure of the building. So they're taking away the entire facade, reuse as much as possible of that, but then put a new facade on top of it. They've also connected these 3 buildings with a new entry in the middle of it, and also put 3 additional floors on top, which are being constructed in wood. So it's a light material, you can still keep the same structure and foundation. They also reused some of the light concrete flooring from the existing building and lifted it up so that they can have that as one of the flooring in the new levels. But they also reused a lot of other materials. This is some of the inner ceilings, the gypsum boards, is some of the joists from the steel joists. It's the radiators, electrical boxes. The list is really long here. So I think it's a really interesting project. And here the same thing is, if you then compare this as the sector reference sort of for office buildings and a new build, and you look at the outcome. And that's not including the demolition that would have been required if you were to build a new building. So it's halved the emissions associated. And another really interesting thing is that it only took 20 months to do this, which is less than half of the time that they would expected it to take if they would have demolished it and built a new building. Which means that for the client, you actually get a lot of additional income because you're able to get new companies in to rent the buildings a lot earlier. Some of the things though that they had challenges was the difficult thing with reuse. based on the current planning and building regulations, which a lot of the time require new materials. And also the shift in cost. So if you compare it, they spent a lot more time and then cost in the design phase and the deconstruct phase. So rather than just demolishing it, you had to really carefully deconstruct this building. But on the other hand, you reduce the cost significantly when it comes to purchasing a new material as well as transport of those materials because they were already on site. So some of the success factors here was really to have interested and solution-oriented project partners. So they handpicked project partners for this project in order to get a team that would work towards the same goal. And then to do calculations, the same thing as before. And what they're saying is a lot of patience and a lot of nagging towards the municipality and the regulators in order to be able to do certain things in here. To do cooperation and to do design details. So we really see here a new role for architects in this. And I really think that if you look at the end result, it looks really nice. So this is the tunnel from the outside. This is how the extended floors look like, what they put on top. This is some of the details from the interior, the new entry that they put in place. Here's how it looked like with the reused carpets, reused internal windows, etc. And then some of the ones that they couldn't use in the existing building, they built a restaurant outside, completely reused parts. So moving on to some new constructions. I have included 2 projects here, and the reason for that is that I wanted to demonstrate that independent on the type of frame that you're using, it's possible to reduce the embodied carbon significantly. So the one on the top here is built with prefabricated concrete elements, and the one at the bottom is mainly using in situ cast concrete, so it's poured on site mainly. And the focus here is on affordable housing. So these are both public housing projects. And they have quite, like, I would say not unique, but they are looking a bit innovatively when it comes to the contract and the tendering. In the project in the top, Hester, this was used as sort of a cooperative agreement with a climate budget that would had a goal set for all the project partners, but also with a bonus tied to it. And then in the bottom one, there was actually a tendering where it was based on 80% on price in the tendering and 20% on CO2. Interesting too, they also had a flexible timeline. So it wasn't set how long exactly when the building needed to be finished. So it gave some leeway in that. Some of the measures taken here is really looking at the resource efficient design. So looking at the form factors, how the structure of the building, the layout. They also worked a lot with optimization of the construction, so really to slim the structural elements based on the specific requirements. Looking at the concrete and having the right quality and exposure class for the specific concrete. So right concrete in the right place, which reduces then the cement content. And then they optimize the concrete recipes, replacing cement with slags or rest products from the steel industry. They also did quite a lot of conscious product choices and worked hard on reducing the reinforcement needs of the concrete and minimize waste. And if we look at the results then, we had about 36% reduction, or between 36 and 50% reduction, yes, compared to sector reference. However, if you look at just the structural frame, this was more than halved in one of the projects and halved in one. And if we also look at the material consumption, I think that's quite interesting. If we compare it to the reference case, they reduced the material consumption quite significantly here too, which means that of course you get reduced costs. And both, as I said, both projects were cost neutral. So the additional time spent in the design phase here as well was actually compensated, and more than compensated in one of the cases with reduced material costs. Some of the challenges that they faced here was that they're working with a lot of different partners, and the competency and the capacity building that were needed in order to actually being able to deliver on this project. And also they also did product developing during the course of the project in order to really reduce to the levels that they wanted to see. But some of the success factors were really close cooperation and focus on resource efficiency at every stage of the project. And also daring to question old norms. So not just satisfying with, this is the way that we always do. No, can we do it differently? And I also want to say, the one with the flexible timeline, it only took 1 month longer to build it, with half the carbon emissions. So just to sum up, some of the success factors that we see to bring forward is really to focus on the resource hierarchy, this one that we see here. To create conditions for close collaborations with the tendering and contract firms. To build engagement throughout the project teams. As I said, dare to question all norms. And to remember the life cycle, of course, so that we don't sub-optimize. But also work on systematic processes and digitization of the processes. And I would say also to expect cost shifts. We will see that the cost, especially I think in the design phase, will increase, but we can reduce that in the later stage to get cost neutrality as a goal. Thank you.